Yes, class. Good evening.
Good evening, ma'am.
All right. So in the last class, we had started with this lesson, chapter number 4, moving charges and magnetism, and we had started with the Biot-Savart's law. We had completed it till there. So no numericals. We didn't do any numericals. We had seen the direction, how to calculate the direction or how to find out the direction of the magnitude of the magnetic field. Magnitude, you people know how to calculate it with the help of Biot-Savart's law. But direction, this is given by right hand thumb rule. So right hand thumb rule says basically what? Before that, magnetic field is proportional to few quantities. That was said by Biot-Savart's. So Atif, can you name one quantity in which magnetic field's magnitude is directly proportional to? Atif?
Sin theta.
Sin theta. Where theta is what?
The angle between the length element and R.
Position vector and it. Yes, right. And Fatima, another quantity? Only sin theta. Something else?
Current.
Current. Exactly. It is directly proportional to I. Hamza, is it inversely proportional to anything?
1 by R square.
1 by R square. 1 by R square, it is directly proportional to 1 by R square, inversely proportional to R square. One more quantity is left, which the magnetic field is directly proportional to. Current is done, sin theta is done, inversely proportional to R square is done. One thing is left. Hiba, can you try? I, sin theta, something else with it.
DL.
DL. Yes, right. DL. DL is the current element. Current element is basically what? This is the wire, a small section of the wire, which has the same direction as the direction of current flowing. All right. Then the constant term that we use. Constant we use. Josefa, can you answer what was the constant? A constant we use in this. Because magnetic field is proportional to all these quantity. There must be a constant. Mu naught, no, not only mu naught divided by 4 pi. Fine, mu naught divided by 4 pi, whose value, this mu naught divided by 4 pi, whose value is 10 to the power minus 7. So this is used the way, you in your Coulomb's law or in your electric field or potential, you were using 9 into 10 to the power 9 for the calculation of constant there, K. That was 1 over 4 pi epsilon naught. Here it is mu naught divided by 4 pi into 10, which is equal to 10 to the power minus 7. So you can replace mu naught as 4 pi into 10 to the power minus 7. So this was Biot-Savart's law. Then two directions we had studied. Means direction will be one only, but we had seen two methods to find it out. First one, that the right hand thumb rule, firstly it said that if current element, this is flowing in one direction, let's say this is the point where I have to find out and this is the direction of current flowing. Firstly, put the curl your fingers towards the point. Thumb gives you the direction, like it is pointing out of the screen, means outwards. The second rule said what? Second rule said, put your thumb along the direction of current. The curvature will give you the direction of magnetic field at both the points. So here also, if you look, curvature is pointing towards me, outwards, like this. It is going outwards. So from both the methods, your answer will be the same. You can use any method, whichever method that is preferred by you. Now, one numerical let's do, because in the last class we didn't do any numerical on Biot-Savart's law. Direct formula based I'll give you. At least try to find out the answer for it. And since it is magnetic field, so answer along with the direction. If you only answer the magnitude, then you won't be getting a complete score, because vector quantity is what? Vector quantity has the magnitude as well as it has the sign direction. So direction have to specify. calculate magnetic field at P point. So magnitude and direction. This is your current element flowing along this x-axis. All right, this is a point where you have to find out. So just try once. And for the direction, you can answer in terms of unit vector as well. I cap, j cap, k cap, minus I cap, whatever is your answers. As you can see, axes are there. So just try. Others also answer. Only two students have answered, Atif and Krishna. So direct formula based question. Magnetic field is given by what? Biot-Savart's law, you know. And the constant, if you're not able to write it, the constant term C, Biot-Savart's law says what? Mu naught I dl sine theta divided by r square and 4 pi. This constant mu naught is written as what? 4 pi into 10 to the power minus 7. Written as 4 pi into 10 to the power minus 7. See, this is the distance position vector given. So any other answers coming, or should I discuss this? So correct answer was given by Atif. Yes, Kulsum. Your direction, Kulsum. Direction also not mention the unit vector. Do mention the direction. Otherwise, your answer will be incomplete. Your magnitude is right, Kulsum. Krishna, just look at the calculations once again. I think some error must be there in your calculations. Are you taking it as 4 pi into 10 to the power minus 7? Just see once again. And others also try. All right, let's discuss it now. So only 3 students have tried. Fine. See, position vector is given to you as 10, the distance from the current element, and the point P that we have chosen, that is 10 meters given. Length is given what? 0.001 meters. Current is given 10 amperes. So just put in all the values. B will be equal to what? Mu naught. Mu naught is 4 pi into 10 to the power minus 7. Then you have current. Krishna, direction. Sarah, is it typing error, or just check your answer once again which you have submitted? Something else is also there. Krishna, direction. Magnitude is now correct. Keep on trying. Others, whoever are there at their end of their answers, just try it. Now see, current is given what? Current is given as 10 amperes. DL, this small length, this is given as 10 to the power minus 3. Yes. 10 to the power minus 3. And then you have what? Sine theta. You can see the angle that is made between the position vector r and the length dl element. This is 90 degree. So it becomes sine 90 degree divided by r square. R is what? 10. So this becomes 10 into 10. And the 4 pi in the denominator. See, 4 pi gets cancelled. This 10 gets cancelled. 10 to the power minus 7, 10 to the power minus 3. It becomes 10 to the power minus 10. And when this 10 goes in the numerator, this becomes 10 to the power minus 11. Now see, regarding the direction, we had done this kind of case in the last class where this was the direction of current element and the point was here. See, let's take any rule which you want. Let's prefer the second method. This is the direction of flow of current element. If I keep it like this, the curling of the fingers is leading in which direction? Downwards. But the point P is upwards. So how will it be? If I place my thumb like this, my fingers like this in the direction of flow of current, and I curl it towards the point. Now see, this is the point. My fingers are getting curled towards the right point, where the thumb is leading outwards, out of the page. So outwards will be what? This was y-axis, this was x-axis, obviously positive z-axis. And the unit vector which we use for positive z-axis, that is k cap. So the complete answer becomes k cap Tesla. Clear? Just note it down. If anyone still has any doubt in the direction or the magnitude, ask me again. I'll repeat the direction once again. Yes, you can just write outwards. You can write out of the page also, you can write outwards also. It's just that when you have different magnetic fields, no, like in this we had only a single magnetic field B whose value was 10 to the power minus 11. If you have various other magnetic fields, we'll see cases where a wire is also there, then you have a semicircle connected to something else, so you have different of values of magnetic field. There what you have to do, if you write there the unit vectors, so it will be easier for you to find out the resultant, like k cap, j cap, I cap in terms of this. But right now for these kinds of questions, writing outwards is also sufficient. So written by now, this was small portion. Okay, if anyone is writing, just stop me, otherwise I'm moving forward. Now see, you can get a very direct question on Biot-Savart's law, but if current is mentioned to you and velocity is mentioned. If current is mentioned to you and velocity is mentioned, then how will you manage? How will you write the magnetic field answer? So we can modify Biot-Savart's law. So in two kinds of question come. Difficult questions do not come from this part, which I'm going to tell you right now. Derivation, this very small derivation for 2 marks can come. How to write Biot-Savart's law in terms of current and velocity. Secondly, current or velocity can be provided to you and Biot-Savart law could be asked. Means magnetic field could be asked. So these two kinds, these things come. This is very easy. Formula of current. See, formula of current is what? Yes, Kulsum, in terms of charge, what is the formula of current? If you have charges, then what is the formula of current?
Q by
If someone was answering.
yes, Q by T.
Q by T. See, why do people forget the definition of current? Current is what? Current is basically rate of flow of charges. Charges that flow for a single second. So rate of flow of charges, that is known as current. So this is what? dq over dt, rate of flow of charges. Whatever amount of coulomb means charge has flown for a single second, that is current. So in the Biot-Savart's law, we have the value of current. So let's put this value and see. Now, since I'm taking dq, let me write dB only. dB will be equal to mu naught by 4 pi. Instead of I am writing dq over dt, I. Then it was what? dl sine theta divided by r square, this much. Now, can anyone in the class tell me what is this quantity?
Velocity.
Yes, velocity, dl over dt. See, remember, you must have done it in the last class, last year. dl over dt means distance divided by time. That is known as velocity, rate of change of displacement. So dl over dt, this becomes velocity. Now we can substitute velocity. So this is a very short thing. It comes in exam. But most of the time, no, your questions will be solved by the Biot-Savart's law main formula for which includes the length and the current. So this you people should just keep in mind. This is dq. This will be v sine theta divided by r square. And in vector form, I have told you people, just divide and multiply the numerator and the denominator with r. That will give you what? R here. If you do this, then dv will be equal to what? Mu naught by 4 pi dq R and V sine theta. Cross product, remember we discussed in the last class on Tuesday, we discussed before ending the class. So this becomes V cross R divided by R cube. Sorry, R cube. This is it. All right. Now see, this can come and direct formula based questions will come. So you people will be able to handle it. But we have various applications of Biot-Savart's law for different, remember we did Gauss theorem. So when we were doing Gauss theorem, we did applications of Gauss law. There we had electric field, calculation of electric field for a plane sheet, for a long wire. Like this, here also we have application of Biot-Savart's law. Application of Biot-Savart's. The first application is to find out the magnetic field due to a straight wire. If you are given a straight wire, then what is the magnetic field? So this derivation is not now included. This magnetic field due to straight wire. This is not now included in your 12th syllabus. Circular one is included, that we'll do. Now straight wires include your finitely long wire also. Finite long wire. And then you have infinitely long wire. Infinitely long wire. Now see, in this also, finite long wire, this is not in NCERT. This is not included in NCERT. Infinitely we'll do. Infinitely we'll do, and we'll see a special case of infinite, which is semi-infinite. You must have heard of. So semi-infinite we'll do, infinite is there. So don't worry about finite wire. Now that's not included. Then we have magnetic field due to circular coil. Now, in case of circular coil also, no, you don't have just a circle. Circle is there, but calculation, if this is a circle, then at the center, there must be, at the center of it, there must be some magnetic field. Then at the axis means what? If this is a circle, then at the axis means this is the axis of it. This is the axis of it. So if you are asked to calculate it over here. So this way, so magnetic field due to circular coil, either it is asked to calculate it at the center or at the axis. At the center or at the axis, either of them. This is included. Now, circular coils have various modifications. It can be a semicircular coil. It can be just a semicircular arc. It can be any arc, just a cut like this arc can be there. So that we'll see, and that we'll see, and derivation is there. So second derivation we'll do, but let me tell you the formula for the infinitely long wire. Formula you can remember, and questions will come from the formula. Magnetic field due to infinitely long wire. Now, two cases I'll tell you. One is infinite, other one is semi-infinite. So let's say this is the first case, case 1. This wire is extending from, let's say, plus infinity, it is extending to minus infinity, completely infinitely long wire. Current I is flowing through it, and this is a point P where magnetic field has to be calculated. So again, this separation we are going to take, this separation, let's say this is A. So it makes an angle of 90 degree over here with this point. So magnetic field formula, you can remember, formula is, and length is also there. Length of this conductor is there, but the current element, that is very small in comparison. The current element, this is very small. So that's why we neglect it and just write A in terms of it. So that's why the formula becomes mu naught I divided by 2 pi A. This is the formula for magnetic field due to infinitely long wire. Mu naught I divided by 2 pi A. See, keep on remembering the formula simultaneously. And I would suggest you to at least highlight the formula or write it separately on a register. It becomes confusing whether it was 4 pi or 2 pi in the denominator, whether there wasn't pi or not, or whether the angle has been included. So these things will become confusing because you won't be getting a question. You can get a question directly to calculate like this, but most of the questions include different shapes. A square is given which is made up of 4 infinite long wires like this. So any kind of question can have a semicircular arc connected by a single wire which is connected to infinitely long wire. Calculate the magnetic field at any point. So each part you should know, then at the end we'll club it and see. Then second case I was telling you about semi-infinite. See, this is case 2. Semi-infinite means it has infinity at one end and the other end is fixed. Means this is not infinite, this is a finite end. Let's say O point is this is a finite end. Whereas this is the infinite end. And the point should lie at the finite end, means the fixed end. Point can lie either at infinity and the point can lie either in the middle of the wire. So the condition for the calculation of this part and whatever is included in your syllabus is that the point, wherever you are calculating, this lies at the end, at one end. So wire, this is known as wire is semi-infinite. The wire is semi-infinite. So the formula of it. So a formula is same with a slight difference. So it's easier for you to remember. Mu naught I by pi A is there. Instead of 2, just write 4. This is the formula of it. And again mentioning you, this is valid when point lies near 1 end. Point lies near 1 end. One more thing, can anyone tell me the nature of the graph if I plot between B and A? This is B, this is A on y-axis magnetic field, and this is x-axis. Yes. Can anyone tell me the nature of the graph? How are B and A related? See the formula, mu naught I by 4 pi A or 2 pi A, both the formula are
proportional.
exactly, Fatima. It is inversely proportional. So B is inversely proportional to what? B is inversely proportional to A. So the graph will be hyperbola. B is inversely proportional by the formula. All right, before moving on to the question of this, just note down all these points. First, note down all these points. Wherever you have issues, wherever you have queries, just ask me. Atif, are you able to hear? Is this audible to you, Atif? Atif is facing severe network issues.
Yes, teacher.
Atif, is this audible to you?
Yes, teacher. Now it's audible. I'm having some issue.
Okay, yes. So wherever you're not able to understand, no, because I think your network issue is there. So just ask me, I'll repeat that part.
Okay.
So you have this current element, current carrying wire. This current is flowing. This is I. I is equal to what? 10 amperes. All right. This is infinitely long wire. This is point. This is one point. This is a point. This is A point. This is B point. This is C point. This separation is 2 meters. This separation is 2 meters. Now see, for the, you have to calculate magnetic field. Calculate magnetic field. Magnetic at A, B, and C, which means all these 3 points. At A, B, and C. Now see, for A point, these are 3 separate questions. All right, I have written them in together. Means for A part, treat it as an infinitely long wire. Just think, this is the wire, this is the point. You have to calculate it at infinite. This infinitely long wire is there. This point is A, and you have to find out the magnetic field. When you reach the B part, solve it. Whatever will be the magnetic field at B because of this wire, that I'll help you. B, you might be facing difficulty. For A, at least you can calculate with the direction, inwards, outwards, with the help of unit vector, whatever you want. For C point, take it as semi-infinite. Semi-infinite means this acts as a semi-infinite wire, and this point is lying at the one fixed end. All right, so these are 3 different parts. So I think B part you people might have difficulty, but at least you can try it. So A is direct formula based, infinitely long wire. C is also formula based, semi-infinitely long wire. Try it, see whatever answers you are getting. Quickly, try it.
You can explain how I got in infinite and semi-infinite?
Infinite and semi-infinite in the above portion or in this question?
In this question.
In this question, see, when you're treating it as for the A part, no, for calculation of A part, forget that C point is there. Just take that wire, have the look on the wire, and this point A is there. So infinitely long wire is there. A point, you have to calculate the magnetic field. You have the formula for infinite wire. So A part is solved. B part, see whatever magnitude you people are getting. Then for the C part, forget A part. Think A part is not there. So this wire becomes your semi-infinite wire, infinity, and a fixed point at one end, where the C point is lying. Separation is 2 meters. You know the formula for semi-infinity. Will you be able to do now?
Yes, Steve.
So all of you try at least. Infinite, just put in the values. Right now you must have written. Others also should answer. Last time only few students answered. Sara, Krishna, Kulsum, and Atif had answered. Others also try. And direction also. Direction means this is the wire. Curl your fingers towards the point. Thumb will give you the direction. You can answer in any way, outwards, inwards, I cap, K cap, J cap, whatever you wish. But others also should try. Atif answer is correct. Try for the B part as well. Sarah, yes, now it's right, Sarah. Yes, the second part which you have submitted, no, right now. That is also right. Fatima. Slight error is there. And direction, see the direction again. And take mu naught as 4 into 4 pi into 10 to the power minus 7. Hamza, magnitude is right. Direction, just check the direction. What will be the direction? I think the best method would be the second method, where place your fingers in the direction of current, curl your fingers towards the point, A point, B point, whichever point. Krishna is correct. C part, okay, Krishna has done the C part as well. All right, A part is right, C part is also right. Okay, Krishna, C part is also correct. Yes, Hamza. Now your complete answer is right. Hamza, try the B part and the C part as well. Krishna, try B part till the time as you've answered both the parts. Shara, perfect. Yes, Shara. This is the exact answer for the C part. Fatima, just check your calculation. I think you will be able to do because your answer is almost close. Uzaifa and Hiba, you both also try. And Fatima, Fatima Munir. You also try. Just see whatever magnitude you are getting. Formula you have written for infinitely long. Atif, yes, Atif. Atif and Krishna. Now try the Atif, Krishna, and Sarah. Try this B part. Hiba, answer for the first part. Yes, Hiba. Right. Hiba, try the second part. B part or C part, any of them. I would suggest you to try the C part first. And Josefa, you also try. And Kulsum, your answers. I'm waiting for your answer, Kulsum. Any specific reason, Krishna and Atif? Both your answers are right. Both of you have sent the same answer. So that's correct. But type me if you think any reason is there. Your answer is right. All the three parts are done. Just take 2 minutes, then we'll discuss the solution. Till the time, others also try. Hamza, yes, Krishna. Let's calculate now. Let's discuss all the answers I've received. BA, magnetic field for infinitely long wire. What was the formula for infinite? Fatima Munir, you tell me. Just look into your notes and tell me. You must have written it, no? Right now, I made you write two formula for infinite and semi-infinite. Just check and tell me what is the formula for infinite. Yes, Fatima. No idea. Even if you don't remember it, just look into your notes. You must have written it down.
Teacher, you asked which Fatima?
Fatima Munir. See, it's mu naught I divided by 2 pi a. For semi-infinite, this becomes 4 pi a, mu naught I by 4 pi a. So formula, remembering the formula is easier. So this is what? This is mu naught I by 2 pi. Now mu naught, what did I tell you? Write mu naught as 4 pi into 10 to the power minus 7. Is this clear now, Fatima? Fatima Munir. Is this clear now, the formula? This is 4 pi into 10 to the power minus 7. Current here, it is flowing 10 divided by 2 pi and A is 2. See, 2 pi into 2 becomes 4 pi. So 4 pi will get cancelled. This becomes what? 10 to the power minus 6. Now see regarding the direction. This is the point. See, regarding the direction of this. This is the point. This is the current, the element that is flowing. If I keep my hand like this, and this is the point, I'll curl my finger in this way. See, the curling of fingers are pointing forwards. That is not the case. If I keep my hand like this, and I curl the fingers, then curling of fingers is leading at this direction, left hand side. So that is not the point. The point is located at here, this point. If I place my hand like this and then curl it, see, in this way, if I curl it like this, now the fingers have curled towards the right point. This was the point that I wanted to find out. So thumb gives the direction of the magnetic field. Magnetic field is pointing where? Magnetic field is leading outwards. All right. So in this case, if you will see, it will lead you where? It will lead you inwards. So just place your, you can use a second rule also if you are getting confused. If you're getting confused with the method second, because method second is easy. Just have to use your right. I showed you with left hand, but you have to apply it with the help of right hand. Right hand. Okay, let me show you with the help of right hand. You see, right hand will directly give you the current. Or let's discuss the second method as well. This is the flow of current like this. This is the curling of fingers. Curling of fingers is leading inwards. So this will be inwards, which was negative z axis. This axis is which axis? Negative z axis. So we can write it as minus k cap test. This is the assignment. Then we have second case B. Atif, you didn't tell the reason. Krishna has told. See, for second part, always remember, if the point lies on the axis, like this B point, this is lying on the axis of it, axis of the current element. Whenever your point lies on the axis, straight away write the magnetic field as 0. Don't even calculate. Just write it as 0. No direction, no magnitude. Simply 0. Why? Because sine theta becomes 0. We haven't done the derivation for this part because it was not now included. But had we done the derivation, we would have seen that sine 90 is coming. That's why we were able to calculate this. At B point, what will happen? Point and the current element both will lie in the same phase. So that makes angle 0 degree and sine 0 becomes 0. So magnetic field at B point, this is 0. And always remember, because most of the questions, different figures will be given, and at the axis point is always mentioned. So at least it is better if you get rid of it and straight away write it as 0. Then third part was what? BC. Yes, that is mu naught I divided by 4 pi A. So mu naught can be written as 4 pi into 10 to the power minus 7. Current is 10. 4 pi is there and 2 is there. So 4 pi gets cancelled. 10 divided by 2 gives you 5 into 10 to the power minus 7. Again, use your right hand. You use your right hand. I'm showing with the help of left hand. Curl your fingers like this. So thumb will lead to which direction? If you curl your fingers, it will lead again inwards. So that becomes minus k cap Tesla. With the right hand only you see. Like this, fingers will get curled, points inwards. That is how you have to calculate. So quickly note it down. One more question I'll give you where two line charges will be there. So quickly note it down. Whoever hasn't written it, and we'll do one more question. And these are infinitely long wires. So wherever nothing is mentioned, no, like in this question also nothing is mentioned. Even in the figures, these are not drawn. So by default, consider it as infinitely long wire. Because for semi-infinite, it will be given, or you can identify by the figure. But otherwise, finite is not now not included. So you can directly do this. Now I think unit vectors you should use for first one and second one. When you calculate B1, then you will calculate B2. According to the unit vector, you will get the right answer. So answer it in terms of I and mu naught only. Mu naught I, A, the answer will be in terms of this only, but add the direction also. Yes, Krishna, only your answer is correct. So only Krishna has submitted the answer is correct. No, Sarah, not in this way. B1, B2, you have to calculate the net magnetic field now, no? So no need to write it B1 and B2 separately and answer it. B1 you have calculated, B2 you have calculated. Now calculate the net magnetic field at point P. Shara, the answer that you have given after that, see, both the currents are different. One is capital I, other one is what? That is 2 into capital I and 2I. Okay, Atif, you have kept the value of mu naught. No? Yes, right. It's fine. It's fine. Any other answers coming? Atif, Sara, and Krishna. Only 3 students. At least, even if you people are getting value of B1 and B2, write that as well. Let's discuss it now. Only 3 students tried. Okay, Fatima has also tried. Hamza, you have kept the value of mu naught. Okay, just see, I think typing error must be there, Hamza. Okay, only B1 you are writing. Fine, fine. divided by A, no, Fatima, or multiplied by A. Just see. Pi into 10 to the power minus 7, 2i divided by A, I think it must be. All right. Okay, fine. Now let's discuss. Direction also please mention. If you mention the direction, then you'll be able to calculate the resultant also. Now see how to do these kinds of questions where different things are given. More we'll see in today's class also we can try it. This is first one, calculation of B1. Net magnetic field is given by what? Net magnetic field is given by B1 plus D2. Okay, direction you are mentioning. Directions are correct. Directions are correct. Yes, Hamza, directions are correct. Hamza, calculate the net. Now you have B1 and B2 as well. See, try the net calculation of net magnetic field. Sara, magnitude is right, but direction. See, I've told you answers in vector quantities are incomplete without direction. So direction, just tell me. Magnitude is right, Sarah. Perfect. Fatima, for net magnetic field, yes, Fatima. Your direction is right, Fatima. See, let's now. B1 will be what? This will be equal to mu naught I by 2 pi A. Mu naught I by 2 pi A. Now see the direction. This is your point P for the first one. Curl your fingers. It is leading where? Inwards. That is minus K cap. This is your first magnetic field. Now the calculation of B2. B2 will be what? Again, mu naught 2I. See, current is 2I this time. Divided by 2 pi A. Now current, direction. This is your point P now for the second one. Curl your finger, it is leading outwards. That is positive K cap. So both the values of magnetic field are there. Now before calculation of net magnetic field, first tell me, is this part clear to all of you?
Yes, teacher.
Yeah, others also?
Yes, ma'am.
Fatima, Hamza, Huzaifa, what about you? Is this clear?
Teacher, the first one, how is it inwards?
First one, see. I'll check. First one, this is the point. No, it is inwards. See, this is the point P and this is my right hand. All right, this is the point P where I have to calculate. Curling the fingers towards the point. Thumb is leading where? Thumb is leading into the page. That is inwards. Check once again, Fatima. For the first one, it will be inwards. Clear?
Yes, teacher.
So B1 is this, B2 is this. Now, just we have to find out the net magnetic field. So this is simple now. This was the task to do. This you people can easily do. This will be mu naught I by 2 pi A minus K cap plus mu naught 2I divided by 2 pi A K cap. So we can do one thing. We can take at least mu naught I by 2 pi A K cap common. What is left? Minus 1 is left. From here, plus 2 is left. So if you substitute this becomes minus 1. This becomes minus 1 plus 2 plus 1. So final answer is what? Mu naught I by 2 pi A into K cap. If you wish, you can put in the values of the mu naught as well to get the answers, like some students have done that. If you put it as 4 pi into 10 to the power minus 7, you can leave your answer till here at this step also. The answer is correct at this step also. But if you substitute, this becomes 2 pi A K cap. 2 pi and 2 is left. That becomes 2 into 10 to the power minus 7 I K cap divided by A. if you have to write in terms of mu naught. Otherwise, just leave your answers at this step as well. That is also correct, sufficient. So all those who have not written, write it down. Then we'll move on to circular wise. Because straight wise we have done. 2 questions we have studied. That's it. Now see, magnetic field at the center of a circular coil. First we are calculating it at the center. Axis we will see later on. Right now we are just calculating magnetic field at the center of this. Now consider a small portion segment, that is DL. Fatima, are you asking something?
It accidentally opened.
Yes, Fatima?
It accidentally opened the mic.
Okay, all right. So see, DL is a very small segment that is we have taken on the wire. This was our wire, complete wire, circular wire is there. So current is flowing right now in clockwise direction. We'll see for anti-clockwise as well. The current can flow in any direction. Right now, I'm just considering it as flowing in clockwise direction. DL always will always be tangential. This will be tangential. So now with the help of this also you can use and calculate the direction with the help of right hand rule. Otherwise, I'll tell you, see, for circular figures, no, because circular figures, your work becomes easier for calculation of direction. As you see the current flowing, just curl your fingers along it, like it is clockwise. So curl your fingers clockwise. Direction of thumb gives the direction of magnetic field. Along the sense of current, if current is flowing anti-clockwise, like this is anti-clockwise, so it gives outwards. Clear? Like this. Move your fingers along the sense of current inwards. Move your fingers along the sense of current outwards. Like this you have to find out. See, understand circular coil very well. Then understanding of semicircular arc, that becomes very easy. All right, that will be easier than this. So just understand this part well, first part, then you will be able to do. Derivation also is repeated. You will be able to learn the derivation by the end of today's classes. Well, no need to even revise it back. You will be able to do it. So magnetic field. Magnetic field due to element dB will be what? According to Biot-Savart's law, mu naught I by I dl sine theta will obviously be 90. So sine 90 degree divided by 4 pi r square. Why you people can see this is the point O center and this is the direction of current element. It acts at 90 degree. So sine theta will become 90 degree. Now see, since a very small segment we have taken, we have to find it on the whole of the length. So let's integrate it. Integration, as I have told you as well, when you have a smaller segment, you want to find out the bigger one. If you add all those small segments, DL plus DL plus DL plus DL entirely, that will give you the complete length. So integration of dB gives you B. Mu naught I by 4 pi r square is there. Integration of DL is there. Can anyone from the class tell me, if we completely keep on adding DL, what will it give? Anyone from the class?
L.
So what is it? Here you have no L in the figure.
2 pi r.
2 pi r, yes, it will be 2 pi r. Length, which you said, Krishna, right? Length. But see, for circle, we don't write or use the term length. No, use circumference. So circumference is given by 2 pi r. So integrating this gives mu naught I divided by 4 pi. This is capital R I have taken, so it becomes capital R square. This becomes 2 pi r. See, 1 r gets cancelled. Pi gets cancelled, and here 2 is left. So magnetic field is what? Magnetic field is mu naught I divided by 2r. This is the formula of magnetic field. Mu naught I divided by 2 capital R. Now see, this is valid when a single coil is given, a single circle is given. Let's say n is the number of turns that are there. More number of coils are there. So if n is the number of turns, so magnetic field will be this. Then B will be equal to n times mu naught I by 2r. This becomes the formula if n number of turns are there. So be sure about number of turns. If number of turns are mentioned to you in the question, do multiply it with the resultant magnetic field or put it in this formula. Let me write the direction as well. I was telling you about the right hand thumb rule. So direction is given by the modified right hand thumb rule. Right hand thumb. This is modified form of it. So you have to curl your fingers along the sense of current. Curl your fingers along the sense of current. Like if the current is flowing like this, so curl your fingers like this. Current is flowing like this, so curl your fingers like this along the sense of current. Then the thumb gives direction of magnetic field. Let's not end here. Let's just discuss example on this. Tell me the direction of current for this one. Tell me the direction for current for this one. This is first one. This is second. At the center, what is the direction of current? Yes, Krishna. Okay, Hamza, second part, Hamza. Yes, Hamza, right. Sara, right. Okay, Hamza, Krishna, Sara, all parts answered completely. Anyone else? Fatima, what's your answer coming? Okay, Hiba, right answer. See, Fatima, curl your fingers. I'll help you. I'll help you. Yes, Hiba, your answer is right. See, Fatima, try to do it. Right now, I'm dictating. Try to do it in your notebook. If you can do it in front of the screen in whichever device you're using, that's also fine. Otherwise, draw it in your notebook and then try. Wherever the current is flowing, like this or like this, wherever, curl your fingers in that manner only. This will be clockwise. This will be anti-clockwise. First, do this. And wherever thumb will point, like this will be outwards. If this will be inwards. Now try, Fatima. Fatima, just if you're still not able to do that, then unmute and then ask me which part you're not able to understand. I'll repeat again. Don't worry, directions become confusing.
These are the first part, what you said.
First part, see, I'll help with the first part and try the second part. Current, Kulsum, yes, right. Kulsum, second answer. Check your second answer. First one is right, Kulsum. Second one is not correct. See, Fatima. This is the circle, motion of circle. Is it clockwise or anti-clockwise? First tell me that.
Clockwise.
Clockwise. So if I curl my fingers like this is which direction?
Clockwise.
This is clockwise. Anti-clockwise. Anti-clockwise. Now or you try it in the notebook. Atif, right. Both the parts are right. And this curling of fingers, see my fingers motion and the motion of current in the circle. Are they same right now? This way.
Yes, teacher.
They are same now. Like this is current flowing. So this is leading where? This is leading into the inwards. Now tell me for the second part. Try it yourself and tell me for the second part. Kulsum, answer for second part. Kulsum. Yes, second part is right. Kulsum. Kulsum, you there right now? Outwards, yes, it will be outwards. Now see, circle is the current is moving in this direction, like this. This is which direction? Anti-clockwise. So curl the finger like this. Thumb gives the direction outwards. This is how you find out. Okay, Kulsum. Yes, I think upwards because it wasn't any answer. No, typing error. Fine. Outwards is the answer. So this becomes outwards. This becomes outwards. Yeah, so this is valid for circular. Fine, so note this down then we'll do for semicircle. Now then semicircle and semicircular arc, this is very easy if you have understood this part. Still, while writing down wherever you're not able to understand, ask me. Because if this is clear, then you will be able to understand the rest of the parts. Even the derivation is entirely same with slight difference. Written till here.
Yes, teacher.
Now, semicircular coil is given. So you have to write it again. Don't write it in this way. In your notebooks, write it again because derivation of semicircular coil also comes. But the difference here, can anyone tell me what will be DL right now?
Pi r.
Pi r. Yes, Krishna. It will be pi r. The circumference of a semicircle. If 2 pi r is for a full circle, semi half circle, it will be 2 pi r by 2. That gives what? That gives pi r. So magnetic field DL will here become 4 pi r square is there. DL will become pi r. So r gets cancelled, pi gets cancelled. Magnetic field is equal to mu naught I divided by 4r. Again, if n number of turns are there, then it will be n mu naught I by 4. So do not write the direction again. Direction is same. So don't write the direction and waste your time. But write it till number of turns. And it's better if you mention the radius as well. Write the R is the radius. Now we have semicircular arc. Arc is given. Semicircular arc is given. Alright, let me redraw the figure. See, in case of semicircle completely subtends an angle of 180 degree. A normal arc, not semicircle. An arc subtends an angle, a random angle. It can subtend any angle. Semicircle specifically subtends angle of 180 degree. That's why we get it like this. So let's say current is flowing I, radius, this is R, angle is alpha. So alpha angle is the angle subtended. Angle subtended by the arc. This is alpha. Angle subtended by the arc is alpha. Now, here again, these things will be the same. These things, angle, sine theta, till here it will be the same. Similarly, difference will come over here when we'll reach this part. So can you tell me what will be DL? Any relation between angle, radius and DL?
Alpha is equal to dl by dr.
R
Yes, what is the relation?
Theta is
Length
equal
of
to
arc.
dl by dr.
Yeah, DL by
Dr.
dr. Yes, right. When you have the length of the arc, when you have the angle subtended by the arc, and you have the radius. The relation is this: length of arc is given by r into angle, whatever is there. So we can write dl as mu naught I divided by 4 pi r square into r alpha. So r will get cancelled. Final answer that we get. This becomes B is equal to mu naught I alpha divided by 4 pi r, where alpha is the angle subtended. Here also, the magnetic field N will be there. Alpha and 4 pi. This will be the formula. All right, so note down this as well. This is for a random circular arc, which is subtending angle of alpha at the center. This is the center. Written? As you'll write it down, no, just text me done. I'm not moving forward, just text me done. So I know that you people have written it down. All right, so I think most of you have completed. Fine. Just revise all these formula, because in the next class we'll begin with a question only, directly question, which will involve all the applications of all these formula. So revise the formula and come and try to submit the assignment of this week by the end of the week. I didn't receive any assignment from this batch, the previous assignment. So at least try to give the assignment by this week on the WhatsApp group you can submit, or on the Learnivio portal as well. Fine.